Hello everyone, in this video I'll be explaining saturated and unsaturated carbon compounds. Now firstly, moving into the concepts of saturated and unsaturated hydrocarbons, let us first discuss what hydrocarbons are. Now hydrocarbons means they are compounds of hydrogen and carbon atom. Let me write here, they are compounds of hydrogen and carbon. Compounds of hydrogen and carbon are known as hydrocarbon. Now hydrocarbon hydrocarbon is classified into two types. The first one is saturated hydrocarbon, and the second one is unsaturated hydrocarbon. Now our saturated hydrocarbon is further classified into alkanes, and then unsaturated we'll be having here it is alkenes, alkenes and alkynes, as well as we have here our aromatic hydrocarbon also. But this the detailed explanation you will be studying in your higher classes, but for now let us just move into the small introductions based according to our class 10 syllabus. Now firstly, alkenes. Now alkenes, they are the simplest hydrocarbons. They are the simplest hydrocarbons. Let me write HC means hydrocarbon. They are the simplest hydrocarbons and they consist of single bond. Here they consist of single bond and they have a general formula of CnH 2n plus 2, where n starts from 1, 2, 3 and so on. Now moving on, alkene. Alkene means they are the double bonded hydrocarbons, double bonded hydrocarbons, and they have a general formula of CnH2n. Now here in double bond our n will start from 2, that I will explain later. Now alkynes, they are of triple bond. They are a form of triple bond, and then the general formula for alkyne is CnH2n minus 2. Here also our n will start from 2, 3 and so on. Now aromatic hydrocarbons, it consists of a benzene ring. Now remember, aromatic means it should consist of a benzene ring. That means it should follow Huckel's rule. That also you'll be studying in your higher classes. Now firstly, let's move on to our saturated alkanes. Now here, the alkanes, now when our n equals to 1. Now n equals to 1 means carbon 1, C is equal to 1, so 2 plus 2, 4. CH4. The first hydrocarbon known and the simplest hydrocarbon known is our CH4 molecule. Now this is one carbon atom is known as methane, METHANE. ANE, the word A means it is single bond. Here ENE means it is double bond, and YNE means it is a triple bond. Now how about we draw the electron dot structure of methanol? We have already drawn this, but now see, let us just draw it again. Carbon, it has 4 valence electron, remember. Now hydrogen, here we have hydrogen. Each hydrogen atom have 1 electron each. They will share their valence electron to form a covalent bond within the molecule. Here they will share a covalent bond. They will share, the carbon and hydrogen atom each share 1 electron to form a covalent molecule. Therefore in methane molecule we have 4 single covalent bonds formed. Now the second molecule, when it is C equals to 2, C2, and then H2 plus 2 into 2, 4 plus 2, we have C2 H6. Now if you want to draw the structure, electron dot structure, just arrange here. We have 1, 2, 3, 4. The second carbon atom here, 1, 2, 3, 4. Now do this here at 6 hydrogen atom. Hydrogen 1, 2, 3, 4, 5 and 6. Now here they will share this electron, 1 electron here, and then they will all, therefore we'll be getting here the structure in this way. carbon, hydrogen, 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 hydrogen. 1, 2, 3, 4, 5, 6. 6 hydrogen atoms and 2 carbon atoms. This is the skeletal structure of 2 carbon atom. It is known ethane. It is known as ethane, ethane. Now moving on to our alkene. Alkene means what? It is double bond. Therefore here our N starts from 2. Now if N equals to 1, a double bond cannot be shared by a single carbon atom. Therefore it should be 2. Therefore when N equals to, we will be having C2H4. Now how do we write this structure? Carbon to carbon double bond, and then carbon fulfilling the tetravalency of carbon atom. 1, 2, 3, 4. 1, 2, 3, and 4. This is the alkene molecule. Therefore, this is our alkene molecule. Now we can have here also 3 carbon atoms we can have. It is known as propene. Now propene, we can have our 3 carbon atoms. 1, 2, 3. Double bond and then single bond here. Fulfill the tetravalency of carbon atom. 1, 2, 3. 1 hydrogen atom. 1, 2, 3, 4. 4 hydrogen atom. This is our propene molecule. Now the third one is our alkynes, the triple bond. Let me write here the triple bond alkynes. Here N also starts from 2, therefore we will be having here C2H2. Now here we have here our C2, C1, 2, 3 triple bond, and then 1 hydrogen atom, C2H2. Now we can have even C3H4 also. C3 means 1, 2, 3. Now 1, 2, 3, 4. 1, 2, 3, 4. Now 1, 2, 3, 4. This is our propyne molecule. 3 carbon atom, it is known as PYNE, propyne. 2 carbon atom, it is known as ETHYNE, ethane. Therefore these are some of the examples of our hydrocarbons. Now our hydrocarbons are also further studied into chains, branches, and ring. Therefore let us study some cyclic and ring structure as well as some chain branches of our hydrocarbons. Now we have here for our here. Now if we have 1, 2, 3 carbon atom, we can turn it into a cyclic structure in this way. 1, 2, 3. Join it and then add hydrogen atom in this way. Therefore we will be getting here a cyclic structure. Now to cyclic hydrocarbon we give the name cyclo. 1, 2, 3 carbon atom, it is known as propane. PROPAN is cyclopropane. Now here cyclic or ring hydrocarbons, they will follow the general formula CnH2n. Now how about C4H8? Now this is known as, this will be our cyclo butane. This will be known as our cyclo C4. 1, 2, 3, 4. C4. Now at 1, 2, 3, 4. Fulfill the tetravalency of carbon atom in this way. And therefore we'll be having here C4 and H8. 1, 2, 3, 4, 5, 6, 7, and 8 hydrogen atom. Therefore this is known as cyclobutane. Now how about C6H6? Now here we can have here our, firstly let's move to cyclohexene. Now instead of C6H6, 6 carbon, 1, 2, 3, 4, 5, and 6. Now attach, fulfill the tetravalency. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is C6H12. This is known as our CYCl or cyclo. 6 carbon atom is known as hex, single bonded, so ANE, cyclohexane. Now remember cyclic hydrocarbons, cyclic compounds are cyclic carbon compounds may be saturated. Saturated means what? Single bond. Or unsaturated. Unsaturated means double bonded. Therefore, for cyclic structure, we will be having our most important example is our C6H6. It is also known as benzene. Now it is an aromatic structure. Aromatic structure. So let's draw the structure. See, 1, 2, 3, 4, 5 and 6. Dash here, double bond. We have here, we'll be having here 1. There will be having here 3 carbon to carbon single bond and 3 carbon to carbon double bond. Here 1, 2, 3, and then 1, 2, 3, 3 carbon to carbon single bond and 3 carbon to carbon double bond. Hydrogen, 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 hydrogen. Now this is known as our C6H6 molecule. 6 carbon atom, 1, 2, 3, 4, 5, 6. 6 hydrogen atom. It is known as our unsaturated aromatic hydrocarbon, which is also known as our benzene molecule. Therefore, this is the concept of our hydrocarbons, which consists of both saturated and unsaturated hydrocarbons. Now let us discuss homologous series. Now we have seen that our carbon atoms can be linked together to form chains of varying lengths. They can be branch also, they can be cyclic also, they can be both saturated and unsaturated also. Now in addition to that, hydrogen atoms or other atoms on the carbon chain can be replaced by any functional groups. The functional groups like we will be having here our halogen Cl or Br, chlorine or bromine. It can be oxygen atom, oxygen, where the functional groups can be alcohol, aldehydes. It can be a ketone or it can be a carboxylic acid. Now alcohols are represented by OH, aldehydes by CHO, ketones by RCOR, and then carboxylic acids by COOH. Now here, therefore, the presence of a functional group such as an alcohol, aldehyde, a ketone, or carboxylic acids, it decides the property of the carbon compound, whether regardless of what type of hydrocarbon it is, whether it can be both, it can be saturated or unsaturated, it can be a straight chain, or it can be cyclic, or it can be aromatic also. Now for example, if we check here, now see for example we have CH3OH, now here C2H5OH, and then C3H7OH. Now if we check here, the difference between these three molecules is they have a difference of only CH2 unit. Now here the three members, they differ only by a CH2 unit. That means here to this, here it was 1 carbon atom, here we have 2, here we have 3 carbon atom. Therefore here 3, 4, 5 it becomes 5. It was 5 plus 2, 6, 7, it becomes C3H7OH. Now these members, they differ only by a CH2 unit. Therefore, such series of compounds in which the same functional group, when they have the same functional group, substitutes for hydrogen atom in a carbon chain. In this carbon chain, it is called a homologous series. I'm repeating again. A series of compounds, in which they have the same functional group. These are the functional groups: OH, OH, that means the alcohol. It can be aldehyde, ketone, or carboxylic acid also. Therefore, a series of compounds in which the same functional group substitutes for hydrogen atom in a carbon chain is called a homologous series. Now we can take here another example also. Here we have CH4. And how about C2H6? Now here again, C2H6, C3H8. Now here we have CH4. Now it was 1 hydrogen atom. It was this here we have CH4, here we have only CH3. One of the hydrogen atom is replaced by OH. Here it is C2H6. Now the hydrogen atom here becomes H5. It is replaced by OH. Here it was H8. Here it is H7 because one of the hydrogen atom has been replaced by an OH group. Therefore, here all these members, they are differing only by a CH2 unit, where one of the hydrogen atom in the carbon chain is replaced by the same functional group. Therefore, such a series, it is known as a homologous series. And therefore, some points to remember here is that the molecular mass, the molecular mass increases. Why? Because the number of carbon atoms are increasing. More the number of carbon atoms, the more the molecular mass increases. That means the weight. And the physical properties also change. Now, here, since the molecular mass, here molecular mass increases because of that the melting and the boiling point also increases. Therefore, these are some of the properties of a homologous series, where the members differ only by a CH2 unit. Therefore, this is the explanation on the hydrocarbons and the homologous series. In the next video, I'll be explaining the chemical properties of carbon compounds. Thank you.